The focus of section 1.4 is going to be the basic rules of algebra. And for me, algebra is where it starts to get a bit more fun. Okay. So like I like all of math, but algebra is really fun for me. So we do need to review a few definitions that we've seen in a previous section. So first of all, algebra is the branch of mathematics that uses variables in place of numbers. So those variables act as placeholders. And if you don't remember, a variable is a letter or symbol that takes the place of some unknown value. So for us, we're typically going to deal with letters. Higher level mathematics, you could see symbols in different, like the Greek alphabet, for example. But for us, we're just going to use regular old letters. So think X's and Y's for the most part. A constant is a fixed value that does not change. So for example, if I had X minus 12, X is a variable term, okay? We don't know what the variable is, it could change. 12 or negative 12 in this case, it is fixed. It's never going to change. It's always going to be negative 12. This right here would be your constant. Okay. A term is a constant by itself, a variable by itself, or the product of a variable and a constant. Okay. Terms are always separated by addition and subtraction, which is pretty nice. It makes it very easy to see where terms begin and end. Also, terms are going to be either positive or negative, and that addition or subtraction sign is a good indication of whether you have a positive or a negative term. So for positive terms, there's either nothing in front of them at the start of an expression, or there's a plus sign in front of them. Negative terms are going to have a minus sign in front of them. A numerical coefficient is the number factor of a variable term. So let's say I had 5x plus 7. Well, we have a variable term right here. And the coefficient is going to be the number factor. So when we look at 5x plus 7, the coefficient of 5x is going to be 5. 7 is just a constant. Now, sometimes it's not as straightforward as this. Sometimes you have hidden ones and negative ones that are actually coefficients. So for example, if I had negative z plus 2, well, z is my variable term, and negative z is really the same thing as negative 1 times z. We just don't write the negative 1. We just put the negative there. So that 1 is assumed. So even though you don't see the 1, the coefficient here is negative 1. Similarly, if I had y minus 4, sorry, I'm kind of getting into, let me scoot that over. Let's say I had y minus 4. Well, that's really negative, or 1, let me change that. That's really just 1 times y minus 4. So the coefficient here would just be 1. So be on the lookout for those coefficients that are 1 and negative 1. We don't generally write the 1. We just either leave it as a plain old variable or we have a negative variable, but that's going to have a coefficient of either 1 or negative 1. Okay? And then finally, we have an algebraic expression is the combination of numbers or constants, variables, and operation symbols. Another definition, algebraic expressions are the sum or difference of terms. So that's not very formal, but if you just take terms and add them and subtract them, you have an algebraic expression, okay? So topic 1 and 2, I'm going to do in a single video because these two properties, they go together very nicely. So when we start our journey into algebra, we do have some properties that we need to be familiar with. And the first one is the commutative property. So the commutative property states that changing the order of add-ins and factors does not change the sum or product. So add-ins are numbers that are being added. The sum is the answer to an addition problem. Factors are numbers that are being multiplied, and a product is the answer to a multiplication problem. So hopefully it goes without saying, this property works for addition and multiplication only. This would not work for subtraction and division because with subtraction and division, order matters, okay? So let's look at these symbolically. The commutative property of addition states that if I have A plus B, that is exactly the same as B plus A. So the order we add in isn't going to change the answer, okay? The commutative property of multiplication, very similar. It says if we have A times B, that's the exact same thing as multiplying B times A, okay? So again, the order we multiply in doesn't matter. So example 1 says use the commutative property to write equivalent expressions. So we're going to take these properties and we're just going to rewrite them by applying the commutative property. And the commutative property just says change the order. So if I have x plus 5, That is the same as writing 5 plus x. I'm going to get the same answer regardless of what x is. If I add the 5 to the x or if I add the x to the 5, I get the same answer. Okay? And then for part B, we have 7 times x. That is the same thing as x times 7. Now, I will say you will almost never see x times 7. You'll probably almost always see 7 times x. But taking x and multiplying it by 7 is no different than taking 7 and multiplying it by x. Okay? Now, the next property is the associative property. So the associative property states that changing the grouping, and remember, when we talk grouping, it's like we group things inside parentheses or grouping symbols. Changing the grouping of addends and factors does not change the sum or product. So again, this property works for multiplication and addition only. This would not necessarily work with subtraction or division, okay? So the associative property of addition says if we have A plus B grouped together and then we add C, it's going to be the exact same thing of having B and C grouped together and then adding A, okay? Please do note, apply or work out what is in parentheses first. Hopefully you remember that from the order of operations. You always take care of what's in your grouping symbols first. Okay, so you always want to apply or do the addition or multiplication or whatever in parentheses first and then do what's outside. Now, associative property of multiplication is the same thing. If we have A and B, that means we multiply A and B first and then we multiply C because the A and B are in parentheses. We multiply it, then we multiply by C. But that's going to be the exact same thing as if we put B and C in parentheses, multiply that first, and then multiply by A. Doesn't really matter. You can group them however you want with addition and multiplication. You're going to get the same answer. So example 2 says use the associative property to write equivalent expressions. So I have 5x plus, in parentheses, 2y plus 7. So according to the order of operations, I would take care of 2y plus 7. But we want to rewrite and get an equivalent expression. Well, because this is addition, I could rewrite this as 5x plus 2y in parentheses and then have the plus 7 outside. I would get the same thing. Regardless of what x and y are, I would get the same thing, okay? We haven't changed the order of the addends, we've just regrouped them, okay? Similarly, we have -3, and then in parentheses, we have 4 times x. If I wanted to come up with an equivalent expression, I could definitely take -3 times 4 in parentheses and then multiply by x. So regrouping these isn't going to change the final product, okay? So you've seen the associative and the commutative property. It's easy to get these confused with each other. So commutative is changing order, associative is changing grouping. So find a way to make sure you understand the difference between these two properties.